All right, so just a little bit about KGI. It's Keck Graduate Institute is our long name there. I work in the Riggs School of Applied Life Sciences. So we have a School of Pharmacy and a School of Applied Life Sciences. Everything is related to human health in some way, shape, or form. So we have programs in 3 main categories: research, industry, and healthcare. So I'm going to talk about 2 engineering programs. Actually, I'm going to mostly just talk about the MSMDE, but I wanted to throw in the other engineering one as well, just in case anyone's interested. On the healthcare side, and this is useful for our programs in that it interfaces with, I'm seeing a little video. We have students that share classes, and so while one set of students might be learning to design devices to treat people, another group of students might be learning to be the physicians, and then they have very different perspectives, and it's useful. So we have a pharmacy, genetic counseling, pre-physician's assistant, and a pre-med certificate as well. On the industry side, this is where I mostly sit. There's 2 programs that are considered engineering degrees. We have our Master of Engineering in Biopharmaceutical Processing and Master of Science in Medical Device Engineering. Can I get a sense of who, so this is the IEEE club, right? So does that mean you're all in electrical engineering?
Yeah, I think it's safe to presume most of us are in electrical, or you might get a couple computer engineers, but I think out of this group, you're probably all electrical here.
Yeah, okay, so where's someone chatted something, but I didn't see it, so I want to turn the chat on.
They said yes. Yeah.
That's just a yes. Okay. Get that back going. All right. So the MEng is probably not your cup of tea, as I'm going to guess, just because I'll tell you very quickly what it is later. Some of you might actually be interested in the Master of Science in Human Genetics and Genomic Data Analytics. So this is for if there are computer scientist people, that's applying it to genomic data and helping process it to help people understand their conditions and stuff. But I'm here for device engineering. A little background on myself. I was an undergrad at Caltech in mechanical engineering, and I took 1 biology course my first quarter there. I didn't do very well. I definitely didn't think I would ever end up in anything related to biology or life science. A long string of events led me to do my PhD in bioengineering. I worked on heart pumps, and then I've been at KGI for quite some time. So when we talk about life sciences at KGI, you know, agriculture and stuff is also considered life science. We're really considering human life sciences. So we have people who do research and worry about pharmaceuticals, biologics, and then my area is medical devices and diagnostics. And I would venture to say that if I had asked people a year ago if they knew what medical diagnostics are or what nucleic acid testing is, they would say no. But you guys have probably all heard of that now with COVID, right?
Yes.
Yeah, right. So it's all the stuff that people are concerned about, the various, from nasal swabs to blood tests, and whether it's antibodies or DNA testing or RNA testing, whether it's masks or ventilators, all of that falls into medical devices and diagnostics, and that's what we study. And then the diagnostics are actually a subset of devices according to the FDA. And so anytime you've had any kind of blood sample taken, actually, I think I have slides. I should move forward on my slides and then we'll see. So just for some definitions, pharmaceuticals are usually small molecules, typically made using synthetic processes. And so Tylenol is a typical example. Biopharmaceutical drugs, or sometimes called biologics for short, are made using living animals or plants or bacteria or yeast. So they are genetically modified in some way, or they have separate DNA inserted into them, and then they produce that biologic drug that we need. That could be a hormone, it could be a vaccine, it could be a whole number of things. And so they do grow them in cells and bacteria. Sometimes they use human and animal cells, and then there's these more sophisticated techniques. It's been a while now, but there was sort of a big uproar about the goat that supposedly makes spider webs through its udders. What they had done, so it's a half truth. They had modified the goat to be able to produce the molecule that spider silk is made out of. So it's not like spider webs were shooting out of its udders, which would be ridiculous and kind of funny. But it was a genetically modified goat. We also have faculty at KGI that work on plant systems, so they modify plants to produce vaccines, and it's a lot easier to grow a crop than to maintain a herd of cattle. All right, devices, woohoo! Yeah, so medical devices are anything that is used to diagnose, treat, mitigate, prevent a condition or disease. And the subtext is that it can't be metabolized and it can't be through chemical action. We have several faculty that work on in vitro diagnostics, so you guys all know what that is nowadays. I used to have to explain that, but well, I'll explain it anyway. Anytime if you've had any kind of sample, spit, blood, urine, stool sample, and tissue samples, any of that, if it goes off to a lab, everything that's associated with that, the chemicals and the equipment, are in vitro diagnostics. We also have faculty that work on drug delivery, so those could be things like insulin pumps, to just injectors, to various ways to get things, to microdosing and whatnot. Those still kind of have a stronger bio aspect to them. My background is mechanical, so I work on, nowadays, well, my undergrad is mechanical, but nowadays I kind of think of myself as a systems engineer. So someone else has to deal with the biology. I care about mechanics, electrical, I do software, fluid transfer, heat transfer, so kind of all the bits and pieces to automate processes. Wearables are really fun. There's like a neat intersection between consumer products and actual health products. Artificial intelligence gets used a bunch for image processing and training people as well. Assistive technology, if you've ever been in a occupational therapy or physical therapy lab, assistive technology is all the stuff to help you do your day-to-day things if you have some kind of condition or disability that needs help. Neurostimulation devices are ones that electrically stimulate your nerves instead of taking drugs, and they're sort of this up-and-coming branch as we learn more and more about our central nervous system and brain. So they're used to stop tremors. For Parkinson's disease patients, they're being experimented on for pain control, weight management, OCD, depression. And one of the really cool things about the concept of neurostimulation is that if it's not working, or if you get some kind of side effect, you just turn the current off. And then it's not, while there's some surgery associated with spider goat. Sorry, I just saw it on the chat. Yeah, so so it can be shut off and then there's no more side effect. It's like, it's reversible, which you can't say with a cutting out a lesion of your brain or taking certain medications. And it takes a lot of people to put together these companies that run stuff. So my guess is that you all want a job when you graduate. So there's the stuff on the early side, so on the left-hand side of my screen, that's related to market research. So this does not mean like making pamphlets, but it means going out and understanding the users, the patients, the providers, the insurance companies, all of that, and seeing who's going to pay for it and how much are they willing to pay. There's the classic R&D type of engineering. And I have the drug discovery because I'm kind of mixing all of the different careers here, but the R&D stuff at the early phases, kind of translating stuff that's coming out of university labs and putting them into new products that haven't been designed before. So that's often an easy idea of a job type for engineers. At least that's when I was an undergrad. I was like thinking like, what else does an engineer do besides R&D? Maybe my scope was limited at the time, but then there's a whole bunch of people that have to support it. So let's say you get to that prototype, then you have to have people who will do the clinical studies and regulatory affairs. So these people go out and test it, prove that it's safe and effective, file that paperwork with the FDA. So it's somewhere between clinical and legal, sell it. And then there's another large downstream portion of jobs available for engineers. So they're kind of on both ends. All the manufacturing and operations, once a prototype is made, I'm going to guess that most of you have built a prototype of something, right? Any?
Yeah, I think that could be a fair assessment.
Have you ever had an opportunity to build something and then consumers actually buy it?
You know, I have not. I've maybe the beginnings of that with some research, but nothing with fully development.
Right, and that's something that, you know, I wouldn't expect undergrads to have had that opportunity before, but really, as a group, because I consider myself one of you, you're trying to solve problems, right? Like you want to create things that help people in some way, shape, or form. Either it makes them healthy, it makes them happy, it makes them entertained, it does something, right? It makes life easier. In the case of medical devices, those things, well, first, the clinical and regulatory, they have to be safe and effective. And part of that then goes into this manufacturing. Being safe means not just the one prototype sitting on your desk, but it means that 3 out of 1,000,000 are allowed to be defective. That's the Six Sigma style of quality control. So you have people who are very much in charge of all the manufacturing processes and equipment processes to make sure that the stuff that's coming off is coming out to spec, and then you have quality engineers that use statistical tools to verify that the stuff that's being made is appropriate. And then there's the kind of on the manufacturing side where the R&D folks kind of integrate with the manufacturing people. Is like, okay, you have this prototype, I want to make it for still safe and effective, but for as little money as possible. And this is the manufacturing equipment we have. We have an injection molder, but we don't have a sheet metal stamper or something of that sort. And so they need to solve things like it takes the assembly person 3 seconds to do this, and it would only take them 1 second to do this. So try and switching up the design a little bit to make it easier to assemble is another type of like engineering type job. There's also project management and stuff where it's more like tracking the progress in people and resources and making decisions about which direction to go with design. Those folks usually have experience being the designer, and then over time they sort of stop doing the design work themselves and start telling other people what choices to make based on the options that they have. All right, so here's our program. This program is in its second year. So we have 3 classes of students. So it's a 2-year engineering master's degree. 2 of the students had already been at KGI for the pre-med program. So those are the 2 tail ends in this photograph. That's Yune and Derek. So they were pre-meds, and then they used the courses that they had done that and done the second year of this MSMDE. They're both going on to medical school. And then this is me with different hair. And then these 3 students, Kelsey, Sam, Tuzo, they are the current second year MSMDE students. So they were the brave souls who started as the first class of students. They're now joined with new formerly pre-med students, and we have 5 fresh first year students. And that plan is to grow it to maybe 20 or 30 students per class. But it is a young group, and we know each other very well because it's pretty small. This program is really designed to get people careers in engineering with med devices, and as a way to do that, we have our students interact with patients and healthcare providers. I'm going to tell you about a fun class that where they get to do that. Learn and apply industry practices to develop and manufacture viable med devices. So this is while you get a strong foundation in undergrad engineering, there's usually not a lot of time to fit in how do you turn that into appropriate designs, documentation, and manufacturing methods. And we have a jillion team projects. Pretty much every single class has a team project. It's the way people work in real life. Most people don't sit in their desk working at a company with nobody else. And we have industry-sponsored projects. So in addition to the capstone, many of the other classes also have industry-sponsored pieces in there. Any questions yet? All right. Have any of you, so electrical engineering is pretty broad, right? You may or may not be interested in med devices, but have any of you had any experiences either working in a hospital or in a healthcare office or anywhere where you got to talk to medical patients and doctors on a regular basis?
Personally, I have not with medical patients. My research is technically for biomedical engineering, but I wouldn't say we do anything with small, because when I think of biomedical, I think of very like compact, small devices that can go inside the body or whatever. But it's been a lot working with like a reaction time or physical therapists type stuff. So it's a little larger of equipment.
So, well, what I'll say here is, even if you're designing things that a patient doesn't touch, right? Like, there's always some kind of end user, and you have to know what problem you're solving, right? So in the case of in vitro diagnostics, a lot of it is the lab facility that does the work. So there you have a physical user as well. If it's going in a patient, you have to convince doctors to use it. You have to convince insurance companies to pay for it. So, and it's okay to start at the, without necessarily talking to people, but there's some skill that I used to be super shy. So shy, you would not believe I'm the same person. And you need practice talking to people who are not other engineers. They're going to understand it differently. So just trying to convince you here to go out there. But what we did in the first year prior to COVID, we had our students go out and do sort of volunteer work at the local hospital, Casa Colina Hospital. They worked with OT, but getting to meet the patients and talk to the doctors, and then coming up with summaries of product needs. So that one was actually, as you said, sort of the larger scale stuff. But collectively, there's still a lot of value in understanding patients and doctors and being able to talk to them. I'm trying to give examples. Like if you're getting a heart stent, the patient really doesn't know. I mean, they don't pick what brand of heart stent they're gonna get. Or vascular stent. The doctor's gonna pick that. But there's still subtleties in how to get them to adopt your product over other ones. All right, keep going. So our curriculum sort of goes from identifying the product need, what is the problem you're solving, coming up with prototypes and learning how to test them, and then transferring that into a design that can be manufacturable. So on the bottom in these circles are different courses we teach. Human factors, the clinical experience one I was talking about. Some computer-aided design and prototyping. So this includes the CAD is in SolidWorks. The prototyping, we have a cool lab I'm going to show in a sec with lots of stuff. And then production methods of how things are actually constructed. And then to give a complete picture, there's some FDA courses, regulatory courses, business, and quality as well. So this is, the program, as I said, is fairly new. So this is our MAD lab, or medical assistive device lab. It is not fully outfitted in these photos. It has been since. We have several different types of 3D printers, a vacuum former, laser cutter, a little electronics bench over here that has soldering station, oscilloscope, and all the good stuff. This lab is used, it's kind of a classroom / maker space / lab. It's all a dry lab. There's no biological things in it. So we teach small classes in here on a normal time. It seats 16, and a COVID time it seats 8. And all the equipment is there and available. And then once the students pass the prototyping class, they have key card access to go in there anytime they want to do projects as they see fit. And then here this is the first day of the prototyping class. I made them make what's called low fidelity prototypes. So things to convey ideas, but made using very simple tools like paper and glue and stuff. So there's a couple of reasons I'm showing this. One, you can see around a little bit more than just the 2 photos that look very bare. But also, I want to mention that our classes are very integrated between programs. So even though there's only a few students in MSMDE at this point, there's many students in the classes, and you share classes with pre-meds, with business students, with OT students, with MSMDE students. And then I have to put that there. Are any of you working on a senior thesis or had a capstone or expect to do a capstone project at the end of undergrad?
Yeah, we all have our own design at the end of undergrad. I am coming up on mine next semester, and I'm starting my senior thesis in a couple weeks. I'm just ordering the parts right now.
And so is that experience, it's in a faculty member's lab, I assume, something related to their research, and then
yeah,
your thesis is individual, right?
Well, so I'm a little different because I'm part of the honors program. The honors program, we get to actually publish a thesis, but normally for the students, you just have a normal senior project that you have to present for a class. But for mine, I do a thesis with a professor that has to like sponsor me almost, and then I present that thesis, but it is individual to me at the end of the work.
Okay, so that's a typical experience, both of the ones you described, and a lot of master's programs will have a master's thesis, so it's working in a lab with a faculty advisor during that second year. But it's definitely aimed much more to the academic community, so towards publishing papers, towards very early phase new discovery type of work. Our program is aimed at getting people industry positions, and one of the ways we do that is with this team master's project, which you said you had somebody present that their sibling goes to KGI. So the TMP is a team-based project. So instead of doing an individual thesis in a lab, you work with a team of students, a faculty advisor, and a corporate sponsor. So KGI sources the projects, so students don't have to go seek out, a company to sponsor them. But they are presenting project. They present a problem statement that they have in their own company that they would normally have a consultant do, and the students act as consultants. So it's very real world experience, and you get to talk to the company weekly in a very in a very standard way that you would have as work experience. The types of projects for the MSMDE would include pieces, some or all of these kinds of pieces, doing some user experience research, design and prototyping, creating a manufacturing strategy. So the project I'm working on right now is with the company to develop larger. They already have sterilization devices for masks, but they want to scale up that product to a larger design to get more throughput. If you think you might be interested in this, it's a big leap of faith, I think, to go directly into a master's program. So we have summer programs that match each of our degree programs to get people to know who we are, help them decide if they want to do it. And our first year, it was entirely in person. This summer, it was entirely online. We did 2 sessions, 2 weeks long. And this is a screenshot of one of our sessions. This following summer, we plan on having both one online program for 2 weeks and an in-person program for 4 weeks. So the folks who are out of state or just have other reasons why they can't come in person, can join the online program, and then the in-person folks can actually prototype something, right? So unfortunately, if you're online, you can't use our equipment to make stuff. So they end on the design phase. That's also why it's a little bit shorter. And then the people that come in person, we do some site visits and we get to prototype it for real. So this is the previous year's program. And there's Sam again. She's the current second year student right now. And these are the only fee associated with them is the $20 application fee. We keep the $20 there because it's just a way to make sure that people are more serious that they want to apply. If that is truly a barrier, let me know and I can work something out. But it's a great way to find out whether you like this field and whether it's something you'd be interested in doing. Also, if you are, I had a question in a previous group about whether we'll be hosting the whether I realistically think we'll be hosting the in-person. It's completely in the plan for us to host the in-person. And if that's something you prefer, then I say apply for the in-person one. And worst case, it gets converted to an online, and then you'll have a choice whether to continue with the online one or not. But there are fewer spots in person than online. So if that's something you want to do that one. I'm gonna go super fast through MEng because you guys are electrical engineers and I'm just guessing that like cell stuff is not up your sleeve. So this is a program for let me even skip there, to go innovate new biologic drugs. So those are the super bio people. And then create all these industrial processes and manufacturing operations. So it can be anything from upscaling biological growth to process control, which includes like flow rates, temperatures, and other aspects in manufacturing. It's kind of like instead of brewing beer, they're brewing cells that make drugs. They have a huge ton of experiential opportunities. I would say the most out of any of our programs in terms of doing TMPs, design projects and internships and the like. And I don't have a lot of info on this. The last time I gave this presentation, there was a student from that program that helped me fill it in. But they also have a matching summer program. So if you know anybody, if you happen to come across somebody who's interested in more of that kind of thing, there is something called the B Suite. And we have, so in general at KGI, we really do value our industry relationships. We don't just talk about them. Our entire advisory board is industry folks. Our board of trustees has industry people, and we bring them into class. Most of the faculty have some kind of industry experience. We help people get into a clinical setting. And since we're really thinking about careers in industry as opposed to academia, we have a lot of these manufacturing and quality and business operations things. We have other programs that are in business and regulatory, and so there's courses in that as well. Professional development. Have you guys heard this word a lot or not?
All the time.
Definitely.
Here and there.
Okay, so how do you develop yourself professionally, right? There's just blanket experience of working, but then that's a little bit of a catch-22 because you're going around and you're like I can't get a job without experience. I can't get experience without a job. Ways that we work with students on these skills, a lot of public speaking, again, in a comfortable setting. People have different, there's some folks are very outgoing. I know from my own experience, I was extremely anxious about public speaking. They got that out of me as a staff member. So that goes through also a lot of presentations. We have networking events galore, including in this online era. We have an entire networking subset of activities that were created to be online to manage that for our students. That includes speaker series, that includes career events, it includes a huge number of alumni that are available to contact. Working within teams, again, getting used to team dynamics, enormous. There's one class that's in the first year that's very well known for its like crazy sides team project, where the entire section of 40 people are a team, and then they have sub teams, and then there's like a management team built just like a company, and it puts people through the ringer a little bit, but it's very realistic experience of what being at a company is like, and the faculty member that runs that, she does a lot of like personality assessments to help people learn how to reflect on themselves, but also how to interact with students that have very different personalities. And then we also have our career services office has a whole program around job placement skills, including not just resume writing, but interview practices and other various practices. And so that's it. I know this is a super long ones here, but this is my email address. If you have any questions or want to send someone else for information, they can use my email address, or they can email admissions. And then if you want to know more about the summer program, that's this first link. And if you want to know like the nitty-gritty details of which classes are in the master's program, that's here. So that is my good stuff. So I'll stop sharing and I'll see myself on a screen with names. Is anyone here interested in medical devices? I hope. One person, maybe?
Yeah, I would be interested, but I'm pretty undetermined still. So
Right.
I'm interested in learning more about it more than anything.
Sure. So, you know, like a 2-week summer program, free of charge, might be something worth trying then, if that's something you're thinking about.
Yeah, definitely. I had a couple questions if you don't mind.
Yeah, go for it.
What do you look for in like the applicants who are looking to apply to the institute? Like what makes them stand out?
So our number of seats and the number of applicants isn't that huge. So I actually, in addition to the admissions office, I personally look through all the applicants as a program director. There's the standard stuff of GREs and GPA type things, but honestly, we found that that's not a very strong indicator of how well people will succeed. So there's the personal statement, which usually needs to connect why you would be interested in the program, because I don't want to have people mismatched where they are not, turn out they're not interested and then miserable for a couple of years, and it's just bad for everybody. A letter of recommendation, so that's somebody that can speak to your sort of perseverance, right? So doing something like doing research where the results aren't guaranteed, right? It's one thing to do a homework set when you know in advance that there's a solution. It's another thing to do design or research where you don't know the solution and you don't know if you're going to come up with it, and like problem solving, attitude, that kind of stuff. Yeah, letter of recommendation, statement, and so yeah, those are the kinds of things. We have a variety of students that have come to KGI. So I wonder, do we have any Long Beach students? I'm trying to think of the current students. I mean, I do believe we have Cal State Long Beach students at KGI. I'm going through each of the students in my head. I don't think we have any in the MSMDE at the moment. Definitely during the summer program. We've had people join in the summer program.
Okay, and then you also referenced like to kind of get to know the audience a little better when you're building like your devices. I was wondering if you had a little more ideas of how you could do that. You kind of referenced like going to the hospital to like get a better perspective of that. Do you have any other examples?
So it's hard in general. A lot of medical devices are initially invented by doctors in the sense that they come up with a need, and then they don't know how to make it, and then they recruit engineers and sort of chit chat. So there's a little bit of networking. I go to a lot of free, what they call like med tech mixers and things, and Irvine, Orange County in general is a very large hub for medical devices. If you get any insight, it's like friends, family, and networking, which is part of why those networking skills are so so important, and they're also hard to develop. So I don't have an easy answer for that. Some other things, if there's any kind of like condition or something that you're particularly interested in, there are advocacy groups and conferences around those as well. So for the assistive technology, there's a big fair that happens at the LA Convention Center that's also free to attend. So that's one way to just sort of like go around and see what kinds of devices other people are making and promoting. And then advocacy groups has patients talking to each other on forums and things, so you can see what goes on. But a lot of the market research is a lot of that type of research is sort of blended with the business people. So that's also part of why we teach business and learning how to communicate with them on what their priorities are versus the design priorities. one of the sad truths is like sometimes you don't end up making, like, the most sophisticated product isn't necessarily the best product, for other reasons around things being hard to use or being too expensive. So even though, and some items, like, yeah, we could make it better, but it's good enough, and there's very little benefit to improve it further, which is not usually, you know, I feel like most of us want to make things, if it can be better, why isn't it better? Have you guys ever seen the video of this YouTuber? She makes these silly devices. Like, she has one that's an alarm clock, which is like a rubber glove that like smacks her in the face like this. Have you guys seen that lady?
Yeah, I actually just saw that yesterday.
You just saw that. So she gave a TED talk. Did you see the TED talk, or did you just see the video of her
No,
face slapping?
one of my friends just sent the video of her face getting slapped.
So she's actually been around a while, and it's a really interesting TED talk of how she got into it through some, like, she started with this like fear of failure, and internally decided, I don't know her name, I will look it up in just a minute, but she decided that if she plans to make something useless and fail, that it's not a failure when it fails, because that was the plan. And then it has like her whole kind of emotional journey around it, which is pretty cool, and it has all the enthusiasm of like getting to build robotics and stuff without worrying about it being the best of the best. I'm gonna try and TED Talk bad robot. The making of shitty robots by Simone Giertz. So her name is, oh, let me find it. Simone Giertz. So that's her name. And you guys have YouTube, you can look it up, but that's her name. It's pretty fun. So I talked about medical devices. I'm curious what you guys are hoping to do with your electrical engineering degrees. There's power electronics, digital electronics, electromechanical control stuff. Do you guys play with Arduinos and Raspberry Pis?
Yeah, that'd be a big part of the projects that we have at the club and stuff. We have a couple projects going on, and one of them is doing, like, a lot of the prototyping has to be done on Arduinos, and obviously a Raspberry Pi is just a more complex Arduino if you want to use Bluetooth or whatever. And so yeah, we do work on that, but personally I think design is really cool. So going into a field of design would definitely be a goal of mine.
Anybody else? I have my little Arduino.
Yeah, well, my concentration is in control systems.
Okay.
I've always been very intrigued by the biomedical industry. So I could find myself going down that path. And so I always want to learn more, and I'm pretty interested in the summer program.
Awesome. Yeah, so there's a ton of room for control systems. Actually, on the bioengineer or the biopharmaceutical side, because all of those, it's a lot of sensors and transducers and stuff to measure, like I said, temperatures and flow rates and pH and all that, and then having robust sensor systems that then communicate and control each other, because batches of drugs can cost millions of dollars. So if you lose that, you're in big luck, in bad shape, I should say. Big luck, that doesn't make any sense. You're in bad shape. So there is some application there. And then in med devices, there's from the side of assistive tech and robotics, that's one area, but there's also, I would say, on the diagnostic side, a lot of real cool things where, for me, I was, the control stuff I was doing was more like temperature control and uniformity and stuff, and doing feedbacks with those. So even though I was never trained as an electrical engineer, I did take several classes, and then from that, as projects came up that needed it, I feel like it's a lot easier to learn a skill when you have an immediate need of something to solve. And so, yeah, I do like little, I'd say like smaller analog circuits, a lot of op amps and things like that. Okay. Then that's all I really had to say. So if you guys come up with questions in the future, or you think you come across another student that might be interested in the summer program, have them apply. It's a rolling admission, so the sooner, I think it's rolling admission after December 15th-ish. I'd have to check. So we kind of hold all the applications, and then whatever comes in by that date, we look at them all together. And then after that, if there's still spaces, we fill them up as people apply that are qualified. And so the sooner the better.